level of complexity in these questions will increase. So today we are going to focus on a type 1 question. On Tuesday, we quite likely will finish off type 1 and we'll do type 2 and maybe get to type 3. In type 1, the object is going straight down. And learners may think, okay, this is an easy thing because it's not doing much in the air. Type 2 is where the object is caught at the same level from which it is thrown. I'm going to take a very typical, very easy example. If you have an object that goes up into the air, reaches a certain maximum height, and comes down to exactly the same level that you threw it from. In other words, it's as if you're throwing it from the ground level and it's returning to the ground level there. Then type 3 was actually the most difficult type you could get, where you got all those changes that occurred with velocity, displacement. Acceleration is constant, but velocity and displacement varied considerably. So in this type here, you've got a building, and you're going to have an object thrown off the edge of the building. So that object is going to go up into the air, reach maximum height, come down to its starting level, and then from that starting level, it's going to go to the ground. So that's your type 3 question. Type 4 is an extension of type 3 actually. It's a hot air balloon. It's very much like a building question, but this time you're basically releasing the object from a hot air balloon. You got a hot air balloon that's rising, and as the hot air balloon is rising, you're going to throw something up into the air. It's going to reach maximum height. It's going to come back down to the same position, and then that object is also going to hit the ground. Now, if you look at type 4 and type 3, they're exactly the same. They're not anything different. Type 5 is an extension of type 3. Is where you have the object thrown up into the air, coming down to the ground, and it actually bounces here. So type 3 and type 5 are virtually the same. Actually, if you take type 3 and mix it with type 2, you're going to get what we call a bouncing ball. So this is basically the added part that you have, which makes this now a type 5. So type 5 starts there and ends here. That's what we call a bouncing ball. Now we need to go through all these different types of questions and show you how they vary. And even in the very first type, I'm not going to do too many questions today because everybody's obviously not here. I think learners need to get used to the idea of actually having a lesson on a Sunday, because this is not going to end and we're not going to stop these lessons as well. But last week was a bit unfortunate that I didn't end up having the lesson. But normally you will have a lesson on a Sunday. Right, let's start. It says a body. Do I have it recording now? Yes, I do. A body of mass 0.25 kilograms falls vertically downwards from rest. Obviously, from rest implies something about the initial velocity there. Right, that means that the initial velocity is 0. Now, I had another learner yesterday and I noticed something. Another way of stating from rest is to state that the object is dropped. So if they tell us that the object is dropped, it means that the initial velocity is going to be 0. 1.1 is a straightforward question. It's simply checking to see whether you actually understand what projectile motion is. Any object in projectile motion will only have the force of gravity acting on them. And when the force of gravity acts on them, the acceleration due to gravity is going to be downwards, and it's going to be 9.8 meters per second squared. So what is the magnitude and direction of the acceleration? The magnitude is 9.8 meters per second squared downwards. Don't say plus 9.8, eh? Actually, that plus is subjective. Right? Some schools take downwards to be positive. I take downwards to be negative. I don't take it to be positive. So this is why I wanted all the learners to be here today, because you can actually see what I told you about yesterday. And you can go back and double check this. In this type 1 question we're going to have our object going downwards. So the object is going below its starting level, not above its starting level. If an object is below its starting level, all your displacements are negative. Because the object is physically moving downwards, your velocity vectors are going to be downwards, which means your velocity is negative. And your acceleration due to gravity is always going to be downwards, so that's also going to be negative. What I want to point out here is that at any point in its motion, the velocity of the object is going to be a negative value, not a positive. The reason why I'm emphasizing this is because there's a tendency for learners to keep the velocities for some reason to be positive. Right, so some learners may be wondering, so when is our displacement positive then? Very simple. Your displacement is positive when the object is projected above its starting position. So here, in this example, in a type 2 question, all your displacements are going to be positive because there's your starting level, and this object is always above the starting level. So if you start here, all the displacements will be positive. Your velocities will be positive for going up and negative for coming down. And your acceleration, whether the object is going up or coming down, the acceleration due to gravity is always downwards. Now, I'm going to expect you to do this at some point. It may not happen initially because some of you haven't started yet, or some of you have just barely started. Please learn these equations of motion. There's no way around it but to remember them. The reason for this, when the questions get difficult, you cannot make the difficulty in the question your search for the correct equation. In simple words, don't make the easy tasks difficult. The easy task is figuring out which equation you're going to use. The only way you're going to figure out which equation you're going to use is if you know the equations off by heart. If you don't learn these equations, you're going to suffer in the easy questions and you're going to suffer in the difficult questions. How do we answer this? We write down all the key pieces of information that we have for each question, and we see which variable we need to find. So I know my initial velocity is 0. I already know that my acceleration is minus 9.8. And for 1.2, they want us to work out the distance it falls in 3 seconds. There is no equation for distance. There's an equation for displacement, yes. So we're going to find the displacement that it falls in a time of 3 seconds with an initial velocity of 0 and an acceleration of minus 9.8. That means after it's gone down 3 seconds, we're going to work out our delta y, which is our displacement. But your displacement is actually your distance without a direction. So effectively, they want you to give us the displacement, but don't state the direction. Anybody knows the equation that relates these variables together? Somebody knows it. Delta y equals to vi delta t plus half a delta t squared. Please don't forget all your deltas everywhere. What we've noticed last year in our examiner's report, if the learners didn't put the deltas and they just wrote t, the examiner marked it wrong. Please ensure that you have the correct equations written down. So your delta y is what you want to find. Your initial velocity is 0. So 0 multiplied by any time is 0. It's half into minus 9.8 into 3 squared. Please don't be afraid of getting a negative answer. That negative is your displacement, not your distance. If you want to write down your distance, you just take out the negative sign there. Answer, please. I think that's 44.1.
Yeah, 44.1.
So the answer here is negative 44.1. I want to explain the meaning of the word negative. Explain the meaning of the negative. That negative is your direction. You started there, you ended there, so there's your displacement vector. That displacement vector is downwards. That's a negative. That negative means down. The 44.1 is the magnitude. So if you want to write out the answer for your distance now, we'll say that the distance is 44.1 meters. The speed after falling 70 meters. Right, so the speed after falling for 70 meters. So what is that? That's your final velocity. So you want to find the final velocity. Your initial velocity is 0. Your acceleration is minus 9.8. And you want to find the final velocity after it has fallen 70 meters. So if you've fallen 70 meters, your delta y is going to be minus 70. Please note you're putting in a vector quantity here. You're not putting in a scalar. That vector quantity has to have a direction attached to it. Because you are putting in your displacement and not your distance, it's a negative based on my convention. And my convention is downward vectors are negative, upward vectors are positive. So the equation that relates these variables together, anyone?
Would it be the VF squared is equal to VI squared plus 2A delta Y?
Correct. Now, before we answer this, I want to just explain something about the use of the calculator here. As I said, all your velocities going down are going to be negative. But there's a tendency amongst learners to put a positive answer. Why? Because the reason is the calculator doesn't give you the negative answer all the time. I'll explain why. VF squared is equal to 0 plus 2 into minus 9.8 into minus 70. Now 2 times minus 9.8 times minus 70 is going to be a positive. Hypothetically, let's assume that VF squared is, let's assume 900. If you try to find VF on your calculator is going to give you just 30, positive 30. It's not going to give you minus 30 as well. But you know that if x squared is equal to some value, then x will be plus or minus the square root of that value. The calculator doesn't give you the negative. So when you're finding out this answer, you need to keep your convention in mind and remember that in this case here, your answer is going to be a negative. Anyone, what is that negative answer? So you're going to take the answer on the calculator and you're going to attach the negative to it because we have taken downwards to be negative. Now, it may seem difficult in this particular scenario where we have to pay so careful attention to these pluses and minuses. But I assure you, once the questions get difficult, keeping a clear convention and a consistent convention is one of the most important things you're going to do. Answer that, please.
37,04.
So minus 37,04 meters per second is your velocity. If you read the question said speed. Speed is the scalar equivalent of this velocity. So tell the examiner below that the speed is 37,04 meters per second. Then the fourth one. The time. So we want to work out delta t. The time required to reach a speed of 25 meters per second. That means you've got your final velocity now to be minus 25 meters per second. Many learners would have forgotten the minus there. Give me a second, please. Let's go back. So the time required to reach the speed of 25 meters per second. That's the speed. This is your velocity. You need the minus there. Your initial is 0 and your acceleration is minus 9.8. Now you may be wondering, why can't I use any of the information above? You can't, because for example, let's assume you say, okay, why can't we use the 3 seconds? Because I guarantee you in 3 seconds, the speed won't be 25 meters per second. In 3 seconds, what will my speed actually be? Anyone? Now that there will be a good question to check to see whether you followed what we did yesterday. Without an equation, can somebody tell me what will my speed be after 3 seconds?
It'd be 29,4.
Very good. As somebody who's actually followed everything. Let me explain how she figured this out. Because your acceleration is 9.8 meters per second squared, after 1 second, it will be 9.8. After 2 seconds, you add another 9.8, it will be 19.6. After 3 seconds, you add another 9.8, it will be 29.4. And because it's downwards, these are all negative values. So when we say that the acceleration is 9.8 meters per second squared, we mean that the velocity changes by 9.8 meters per second every second. So I guarantee you this time here, if you're starting off with an initial velocity of 0, this time should be about 2.54 seconds, roughly. I don't know exactly what it is, but it should be around there. Let's see what it is. The equation that relates these variables together, as I said, don't make finding the equation the difficult part. It's VF equals to VI plus A delta T. Your VF is minus 25. Your VI is 0. The acceleration is minus 9.8 multiplied by delta T. Minus 25 divided by minus 9.8 will give you your answer for T to be positive. By the way, T can never be negative. If you're calculating a time value and it's working out to be negative, it means that you messed up your convention somewhere. Go back and correct it. What's the answer? 2.54.
It's 2,55.
55. Okay. Right. And there we have it. That is as easy as you can get them. Can you get something as easy as this? Maybe one of these questions can come out, which is super easy. But to give you an idea, a taste of what an exam type question will look like for an object that is dropped, have a look at question 2. Is it difficult? Not really difficult. It just requires a bit of thought, right? There is no simultaneous equations here for some of my friends who've done questions similar to this, right? But it requires an approach or a method to do this. I'm going to give you 2 minutes and then I'm going to ask you for your method. So you got 2 minutes to think about this. I'll be back in a minute. Okay, anyone with a method? Somebody has a method. All right, let's read. A stone is dropped from the top of a building with a height of 125 meters. Dropped means that the initial velocity of this first stone is 0. Height of 125 meters means that this stone is going to go down and the delta y when it's going to be hitting the ground is going to be minus 125. One second later, a second stone is projected downwards. Projected means thrown down with an initial velocity from the top of the same building. If both stones reach the ground simultaneously, calculate the velocity of the second stone. I think they meant initial velocity of the second stone, yeah. So here you have the second stone now. This second stone is thrown down with an unknown initial velocity, which we're going to find. It's going to cover the same delta y of minus 125. But it's thrown 1 second later. What does that mean in terms of the time taken for the red stone to reach the ground and the time taken for the green stone to reach the ground? If they both reach the ground at the same time. Let me give you an example. Let's assume the red stone took 5 seconds to reach the ground, which weirdly I think is the answer for the first one. How many seconds would the next one take to reach the ground? If it is thrown 1 second later and they both reach the ground at the same time. Anyone? How many seconds?
4 seconds.
Correct. Because this because the second stone is spending less time in the air. How do we know it's spending less time in the air? Because the question states quite clearly it's dropped or thrown 1 second later. If it's thrown 1 second later, it's going to have less time to spend in the air compared to the first stone. Therefore, the next stone is going to be 4 seconds only, 5 minus the 1. So what I'm going to do is I'm going to work out the time it takes for the first stone to reach the ground. Remember, both of them have the same acceleration. So for stone 1, I'm going to work out the time it takes to reach the ground. Anyone? What's the equation I'm going to use with these variables? Vi is 0, delta y is minus 125, acceleration is minus 9.8, and we need to work out our delta t there. I know some of you know the equations, so you know you can give it to me. I'll wait for you.
So delta x is equal to vi delta t plus half acceleration times by delta t squared.
Very good. So if you use delta x in school, please feel free and use delta x. There's nothing wrong with it. But I'm just a fan of using delta y. So your delta y is minus 125. Your initial velocity is 0. Half into minus 9.8 to delta t squared. That's minus 4.9. But can someone do this for me? Divide by minus 4.9 and square root it. I'm guessing 5.04. I could be wrong. What's the answer?
It's 5,04. 05, sorry.
You sure about this?
Let me double check.
So I'm getting the same.
Okay. Okay, that was pretty close there. Alright, so 5.05 seconds. So if the first stone took 5.05 seconds, and the second stone was thrown 1 second later, the second stone will be 5.05 minus 1, which means it was 4.05 seconds in the air, covering the same displacement, and the only way it could have caught up with the first stone is if you threw the first stone down with an initial velocity. Remember, that initial velocity is going to be a negative value as well. So let's go for it. It's going to be the same equation. Oh, somebody left. So delta y equals to vi delta t plus half a delta t squared. Your delta y is still minus 125. Your vi we're going to find this time. Your time is 4.05. Half into minus 9.8 into 4.05 squared. I would suggest you learning to use the equation solver, everyone, and just plugging this into the equation solver. Just want to explain what this equation solver is all about. I'm sure you all know about it. It's just going to make our life very easy in physics. We don't have to show any excessive working over here. So it was minus 125 equals to 4.05x. Minus 4.9, and your time was 4.05 squared. Oh, so it already solved it for me. There's your answer for x. Minus 11.019, which is minus 11.02. But just try and do it like this. It's going to make your life easy. There's no marks for showing all the steps in terms of the maths. So VI is minus 11.02 meters per second. If you go back to the question, it says calculate the velocity of the projection of the second stone. Because it said velocity, you must provide both the magnitude and the direction. There. So that answer there has to be 11.02 meters per second downwards. Now, I want to also just quickly point out something over here that I'm starting to notice with grade 12 learners. This minus here is an indicator of your direction, which we've written down in words there. This part here is your magnitude, which is there. Please don't put minus there and state downwards, because they're going to mark that wrong. Because I've seen lots of learners do that. Magnitude must be free of the minus. Don't put that down. Put down the meaning of the minus in words next to that, and that will be your answer. Right, boys and girls, the other thing I want to just point out is that there's a whole series of difficult questions in this section here. My main aim for today was to introduce you to the equations and some very, in my opinion as well, straightforward questions on type 1. But on Tuesday, we're going to do at least 2 questions on type 1 that are going to be quite difficult, where we have an object going downwards, but it's not going to be an easy question. The reason for doing those questions on the other day is because most of the learners are normally there on a Tuesday. And I'd like everybody to actually attend those lessons where at the end of each type, you can actually see the level of difficulty. This section here in your exam is not like momentum. I can tell you historically, momentum has been an easy question compared to vertical projectile motion in the last 10 years. The examiner is getting very creative and is coming up with newer ways of testing this. So you have to know your basic principles and all the different scenarios that ground this section here properly. So that if he does give you a slightly, of a curveball scenario, you'll still know how to work with it, provided you know the basics of all of this. So we're going to finish off type 1 in the next lesson, and we're going to do type 2 as well. Definitely next week, Friday, you're going to have an additional lesson in this section. May not be a very long lesson, but I'm going to finish off type 2 and start off type 3 because this is where we need to be at by Friday. The reason for this is quite simply because these questions here are the difficult ones. They form the basis of all the hard ones, and hopefully we can get to hot air balloons and bouncing ball questions by the weekend. By next week, not this coming week, the following week, I want to be starting organic chemistry as well. Right, and the reason for that is because it's a long section. And the other reason for that is because some of us are going to be fasting in March, and the beginning of March is going to be a bit of a strange period for tuition. I'm going to be catching up for time lost at various points, and I'm hoping that all of you can actually attend. All right, so the people that are not here asked me to please hold on until Tuesday for the difficult questions. I'm going to put up the video for this as well. If you missed yesterday's, you may want to watch yesterday's and today's so that you are ready for the harder questions that are going to come up on Tuesday. So Tuesday's questions are going to be much more challenging than this, and you may have finished this section, but you may have not seen difficult questions on just type 1. Come and put this up now. As soon as I get the recording link, I'll send it to you and we'll take it from there. Please note that the Sunday lesson is actually free. There's no payment for the Sunday lesson. You're only paying for 3 lessons a week. If there's 5, 6, 7 lessons in the week, you don't pay for anything more than 3. And quite likely from this coming week, you're going to have a 5th lesson. So only 3 per week if you're keeping track of your lessons. Thanks, guys. We'll see each other on Tuesday now.